Hello everybody. In this video I will show you how to solve simple separable differential equations. We will go through two examples where we find general solutions, and we will also solve an initial value problem. So the first thing we're going to discuss is the form of differential equations that we can classify as separable. So we're looking for equations that have the following form: g of y times y prime of t is equal to h of t. And the idea here is that you have a function of y only times its derivative, and then that's equal to a function of the independent variable only. Okay, so that's the type that you're looking for when searching for separable differential equations and trying to determine if this equation is indeed separable. Okay, so the idea is then what? We could separate this equation as follows. Y of prime of t is dy dt. Okay, so that means we can rewrite it as g of y dy is equal to h of t dt. Okay, so what does that mean? If these two expressions are equal, we should be able to integrate them without changing the equality sign. Okay, once you do this, on the left you'll get an expression of y is equal to an expression of t. So notice, for us to do this, we should have these matching variables, right? Separation of variables. Move everything with one variable on one side, everything else on the other. Okay, so that's the basic idea, and you will see it, it will click a little bit better once we do some problems. So let's go ahead and do examples. Okay, so example 1, it says the following: dy dx is equal to y times x squared plus 1. Okay, I would like to separate this, right? Meaning have only y expression on the right or on the left. It doesn't matter which side, okay? And then everything else on the other side. So we're going to divide by y. Okay, so we have x squared plus 1 on the right. So now we have 1 over y dy is equal to x squared plus 1 dx. And now we can integrate this. Okay, so this is natural log of absolute value of y is equal to 1/3 x cubed plus x plus c. This is what we're going to call an implicit form, right? We don't have an expression of y is equal to a function of x, but for this particular problem we can solve for y by exponentiation. So y is equal to e to the power 1/3 x cubed plus x plus c. Now recall that e to the power of c, that's just a constant. Okay, so we can rewrite this as a times e to the power 1/3 x cubed plus x. Okay, so let me make a note here. A is just e to the power of c. Okay, so your explicit solution is this right here. This is explicit. Explicit means we have y is a function of x. Okay, in implicit form we said natural log of y is a function of x. All right, so that's it. So what we've done, we've separated our equation such that we had an expression in terms of y on one side and x on the other, and then we just integrate it. Okay, let's take a look at a second example. Okay, here we have y prime of t times e to the t over 2 is equal to y squared plus 4. Okay, what are we going to do here? Let's see. Let's rewrite it as dy dt e to the t over 2 is equal to y squared plus 4. So we need to have y on the left, t on the right. So we're going to divide by y squared plus 4. Okay. And then what? Multiply by e to the negative t over 2. Okay. So that's how we separate the variables. Okay. We haven't separated just yet because we have dt on the left. So we multiply by dt on each side. Okay. And we get the following expression. Now, everything that we have here is in terms of y. Everything that we have here is in terms of t. We can integrate it. Okay. All right. So both of these integrals are straightforward. Okay. The one on the left, this is 1/2 arctangent of y over 2. If you need to review this integration technique, please do that. You can do it by u substitution. Okay. On the right, this is also straightforward, right? So this is negative 2 e to the negative t over 2 plus c. Okay. Let's multiply everything by 2 to get rid of this 1/2 over here. So arctangent of y over 2 is negative 4 e to the negative t over 2 plus c. Okay, we don't need to multiply that c by 2. We just still know this is a constant. Okay, so now we can solve for y over 2. This is tangent c minus 4e to the power negative t over 2. And one more thing, we need to multiply this by 2. So it's 2 tangent c minus 4e to the negative t over 2. Okay, and this is your explicit solution. Still in general form, right? Okay, we do not have initial condition. Okay, so now that we've done 2 problems of this type, let's take a look at an initial value problem by using separation of variables. So this is your example 3. Okay, we have y prime of x is equal to y cosine x. Okay, so we're going to divide by y. Oh, I forgot to give you the initial condition. Y of 0 is equal to 3. Okay, so divide by y, we get 1 over y dy dx, and then cosine x. Okay, so this is 1 over y dy is equal to cosine x dx. We take the integral of each side. We get natural log of absolute value of y on the left. We get sine of x plus c on the right. Again, this is an implicit form. We need to do exponentiation. So y is equal to e to the power sine x plus c. Okay? Now, what is this that we have? We have the initial condition y of 0 is equal to 3. Let me rewrite my function as y is equal to some constant a times e to the power sine of x. Okay, and if we evaluate this at 0, we should get 3. Sine of 0 is 0, e to the 0 is 1. If this is 3, that means a is equal to 3. Okay, so your final answer for this initial value problem is y is equal to 3 times e to the power sine of x. Okay, all right, so in this video we discussed the general form of a separable differential equation, how to solve it, and we looked at the initial value problem over here. So in the next video I will show you some more complicated examples where we get a solution in an implicit form and we cannot solve for y. And so how do we handle those problems? Okay, thank you for watching.